Hi, my name is Sam Gray, and today I'm going to be discussing the CRJ fuel system. We will go over the layout, we'll talk about the various components of the fuel system, we'll talk about some of the redundancies, and we will also go over some of the system limitations for the CRJ fuel system. All right, so here's the fuel system diagram for the aircraft. There's some good stuff to take away here. You can see the layout of the tanks. You've got your right-hand main tank and your left-hand main tank. And then there in the center, you have your collector tanks. And you can also see all of the refuel, defuel, control panel location. And you can see the various fueling points for the aircraft. So if you look on the base of that right wing, you'll see the single point refuel defuel adapter. Apparently this is the most used spot in order to refuel the aircraft as opposed to using the fill caps on the right wing and the left wing. All right, so a little bit more about those refueling points. The right wing base refuel point is the one that's most used, as we just talked about, and there are four total fuel points. So you got two in the wings, one center wing, and one refuel. So one in each wing, one center wing, and one refuel for a total of four fuel ports. All right, so the fuel panel aboard the CRJ looks a little something like this. This is pretty cool to me. So as you see those little red figures there, the red values, that's where you can see the quantity for all of the fuel tanks. And also there's a headset jack on the fuel panel for the fuelers or the maintenance personnel to plug a headset into, and it allows them to speak with the pilots. So, maybe there's a maintenance issue, or maybe there's an issue with the fuel panel, or maybe the fuelers are seeing some sort of weird values thrown up there on the fuel panel, and they want to talk to the pilots quickly and bring it up. This allows them to do that. So the power switch there is going to enable the fuel crossflow automatically, and you can swap between manual and auto mode on the fuel panel, and the fuel tank quantities are displayed there where the red figures are, as said previously. Okay, so the CRJ fuel system, here's a little bit of a layout that kind of talks about the different components and the fuel flow, sort of indicative of the fuel flow for this diagram. So 6 ejector pumps total, and then there's three fuel pumps. You have a boost pump in the left wing, a boost pump in the right wing, and then you also have the crossflow APU pump, and we'll get into how that APU pump is beneficial here shortly. So most of the fuel system is gravity fed. This aircraft isn't designed to be pulling huge G maneuvers. You're not going inverted all the time, anything crazy like that. It's not a fighter jet. However, we do have some things on board to assist with negative G situations, and we will get into that. But we also have 2 electric boost pumps. This helps us sort of kickstart the fuel flow initially when you're spooling the aircraft up, and that runs off of a 28 volt system. You also have fuel temperature systems, and those are equipped in each engine. You got engine fuel filters, of course, and a fuel oil heat exchanger, so that helps kind of regulate the temperature of the fuel going through the system. All right, so fuel tanks. You got 2 main tanks in the wings. These are both have a capacity of 4,760 pounds, and the center tank with a capacity of 4,998 pounds. One thing that I thought was cool about the tanks in the wings is that they're compartmentalized, so it's not just one big tank. They're actually sectioned off, and this helps with a lot of stuff. So it helps with load factor, it helps with weight and balance. It also kind of helps to prevent fuel imbalances, right? So if you're constantly banking, you've got that fuel, gravity is taking that fuel into that low wing, and that can cause complications with your fuel burn rate, your fuel imbalance, and the actual just general weight and balance and load of your aircraft. All right, so how does the fuel flow in the CRJ? Well, each engine, the fuel flows directly from that center tank that we saw in the diagram out to the main tanks, then the collector tanks, and from the collector tanks, the fuel is going to be delivered into the engine by the main injector or the boost pump. Now, we also have the APU that can assist in fuel feed. So the APU will feed fuel in a negative G situation, kind of like we talked about earlier. So if you are in a negative G situation, being a mostly gravity-fed fuel system, the APU will kind of have your back in that situation. So how does the fuel flow from the APU? It's pretty simple. The fuel is going to flow from the main tanks into the cross flow tank and then into the APU, or into the cross flow then into the APU. Okay, so fuel level indicators. This is important to know. Every aircraft or UAS platform that I've dealt with in the past, that's, one thing I learned about is how the fuel level indicators work and what type they have. Some aircraft have floats, some have magnetic fuel level indicators, others have little probes. It varies based off of whichever platform you're working with. So in the CRJ, it's equipped with what they call magnetic fuel level indicators. There's 5 of them. And they also have fuel quantity probes, so you get a little bit of redundancy there. Each main fuel tank in the wings has 2 sensors. You got one inboard and one outboard, and the center tank also has its own single sensor. On board, you got a fuel system computer that's going to help you out. Like I said, it's mostly gravity fed, so when you're pitching and you're rolling, I talked about how your fuel level indicators are going to vary, especially that's more so applicable for simpler aircraft, smaller aircraft. The CRJ, however, is equipped with the fuel system computer, and it kind of helps to correct for pitch and roll. So you get more of an accurate reading. And like I said, there's other things in place that are preventing the complications from fuel sloshing around or being one-sided. So you also have your fuel temperature indicator that's located in the left wing, and that's quite important because that's one of our system limitations. And it's good to know your fuel temperature indicator. So we have different temperature limitations for multiple kinds of fuel, just because all fuels are different, and it's important to know those temperature limitations for each one. And you have a temperature indicator to display that value for you as a pilot. All right, so system limitations. As I just said, we have temperature limitations for each fuel. JP8 is negative 37 Celsius, Jet A is negative 30 Celsius, Jet A1 is negative 37 Celsius, JP5 is negative 36 Celsius. So our max fuel load is going to be 14,305 pounds, or 2,135 gallons. The max fuel imbalance is 800 pounds. If you do reach this max fuel imbalance, the aircraft or the fuel system computer is going to generate a fuel imbalance caution that'll pop up on your flight display. Then you have your takeoff temperature limitation for your fuel of 5 Celsius. Like I said, it's a good thing we have those fuel temperature sensors on board, or that fuel temperature sensor on the left wing. But yep, that's all of the system limitations, and it was a pleasure learning about the fuel system on board the CRJ. Thanks.